Good day, Irche 2017. It was so unfortunate that I was not able to join you on this conference due to conflict of schedules. I am Daniel Jacinto, Associate Dean of the Institute of Business Management, Isabela State University, Cabagan Campus, Philippines. My field of specialization is that I am a civil engineer, and I've been working in the government for almost 34 years. My paper is about the occupants' conservation practices and attitudes on energy consumption, the case in Isabela State University at Cabagan, Isabela, co-authored by Geraldine J. Pagigan. The location of the study site is located on the northern part of the Philippines. It is called the Cagayan Valley region. The Isabela State University at Cabagan, Isabela is situated at the middle part of the province of Isabela. To the east, it is the Pacific Ocean. To the west, the Caraballo Mountains. To the south, the province of Quirino and Nueva Vizcaya. And to the north is the province of Cagayan. This is the land use plan of the campus. The academic core is approximately 2 kilometers away from the national highway. The elevation is 50 meters above sea level. A total of 5 buildings were included, specifically big academic buildings, namely the College of Teacher Education, the College of Forestry and Environmental Management, the College of Development, Communication and Arts and Sciences, the Department of Social Sciences, and the Provincial Technical Institute of Agriculture. The objectives of the study. This study evaluated specifically the awareness and level of implementation of the occupants of the buildings on energy conservation policy of the campus. It also seeks to determine the significant differences on the energy consumption of the buildings and determine the most conservative occupants among the 5 academic buildings and determine the relationship of occupants' attitude on building energy consumption. Table 2 shows the distribution of respondents per building and gender. The occupants of the buildings consist of faculty and staff and students. The total number of respondents amounted to 107, 50 male and 57 female. As can be gleaned on Table 3, the annual energy consumption of the buildings from year 2011 to 2015, it shows that there's an increase in energy consumption from 37,246 kilowatt hour in year 2011 to 68,697 kilowatt hour in year 2015. Table 3A is the result on the analysis of variance on the significant differences of the energy consumption of each building from 2012 to 2015. As can be seen, the average difference in the energy consumption of the paired building increases annually. In the analysis of variance, it revealed that there is a significant difference in the energy consumption of all the buildings annually, which started from year 2012 to 2015. From year 2012 to 2015, most buildings have significant differences at 0.05 level, except for the Provincial Technical Institute of Agriculture building and the Department of Social Sciences building. However, the differences were caused by increase and decrease of the number of occupants and the number of electrical fixtures on cooling and ventilation installed in the buildings. Table 3B shows the multiple comparisons on the energy consumptions of the buildings. As can be observed on the table, it clearly indicates that there is a significant difference on the change in annual energy consumption of each buildings. It revealed that there is a significant difference at 0.05 level for three buildings, the CDCAS, CFEM, and CTE. The differences were caused by the increase and decrease of the number of occupants and the number of electrical fixtures for cooling and ventilation. Table 4 shows the 2015 annual energy consumption of each building. As can be observed, it shows that per occupant from the DSS building has the lowest energy consumption per capita with 1.16 kilowatt-hour, while the occupants from the CDCAS building has the highest with 5.63 kilowatt-hour. The CTE building with the highest energy consumption among the five buildings has only 3.14 kilowatt per hour per occupant. The result depends on the number of occupants and electrical fixtures in the buildings. For the DSS, it is most populated, but it has less electrical fixtures. At the CTE building, it is most populated, but with more electrical fixtures. And at the CDCAS building, it has less occupants, but it has more electrical fixtures. Based on the result from Table 5, Occupants' Awareness on Campus Policy on Energy Conservation, the occupants from the CTE building, being the most informed and aware of the policy, ranks number 1 with a mean of 4.48. And occupants from the CDCAS building with a mean of 4.21, being the lowest. On occupants' compliance on campus policy on energy conservation, it shows that CTE has the highest with 4.38 and is fully compliant, and it ranks first. And the lowest is the Department of Social Sciences with a mean of 4.05. Descriptive quality is compliant, and it is ranked 5. Table 7 shows the distribution of occupants' frequency of response to their implementation of the policy. The buildings were grouped to the annual level of energy consumption to very high, 20,000 kilowatt-hour per year and above, average below 20,000 to 10,000 kilowatt-hour per year, and low, below 10,000 kilowatt-hour per year consumer of energy. The occupants' perception on the indoor environment quality of the buildings. Energy consumption of buildings is influenced by the poor indoor environmental condition in the building. Using the chi-square test, the computed value is 32.764. The chi-square test values are 21.026 and 26.217. Based on the computed value, it is greater. Therefore, there is enough evidence to conclude that the occupants' compliance and implementation of the policy on energy consumption of the buildings has significant effect on the energy consumption of the building. For the conclusions and recommendations, the findings of this study points out the attitude and compliance to the building energy conservation policy by the occupants has significant influence on the energy consumption. This clearly indicates that occupants' attitude and compliance to the energy consumption policy and building energy consumption has a relationship. The researcher further recommends to conduct a follow-up research to this study to include the succeeding years in the energy consumption of the buildings. It is further recommended to determine if there is difference between genders, male or female, age distributions, on their attitude and behavior on the energy consumption of the buildings. This ends my presentation. Magbalo, thank you. God bless. Iriche 2017-2018. Mabuhay Philippines.